So this is the inverse of A. Here's your 9754. And then you want to do basically, if you have two that are like completely opposite, one's got to be 5, and then this is 9 as a product. One's got to be negative. And then when you add, you're going to get your 0. Then you can carry it out through the rest of them. Once you've done that, then you get this form, and then the next one is to put a 0 here. So that's just a -7 times this row, and then add it to row 1, and you get a 0 here. And then you just got to divide out by the 9. That's your 1/9. So row 1 over 9, or just 1/9 row 1, multiply through. So then we again got the identity matrix, and here's your inverse. And this was a check. You take your matrix, your given matrix, multiply by what you found, and show that it's the identity matrix. So if you ever do this and you don't get the identity matrix, then you just say, no, they're not inverses. Okay, here's the next one. Okay, so this is the one I asked you to do as well last time. Okay, this is a 3x3. I'm not going to go through all the details, but it'll be in the notes when I post the notes, but here is the outline. So you want to get zeros down here first, and then that's always your goal. So here's your row echelon form, that's what this is called. And then you put in your zeros up here, and then lastly you do this one. So it's that order. So it's first these two, then this one. Here, I'll do it like this. So first these two, then this one, then these two, then this one. Carrying out all those operations. So this one's all done. This one you get some nice fractions, a little facetious there. Okay, so here's your inverse, and we're going to use it when we talk about the matrix equation as well later. All right, so let's talk about that. So the matrix equation looks like this. It's so we're going to use this form AX equal to B, where A is a matrix and B is a column vector. So where X, and we call that a column vector, or it's just a n by 1 matrix. So you say x1, oops, don't need that on there. x1, x2, etc. to x sub n. So that's your form of x. And if x is a unique solution to the system, then we say A inverse exists, and x equals A inverse times B. B is also, let me just put this here, is also a column vector. I'll call it A, B, C, etc. because of the way it multiplies. So those would be like your solutions, x, y, z, like an ordered triple or ordered double, that kind of thing. That's what B is in that form. Sometimes they use lowercase b. So here's the idea. If x equals this form, so x1, x2 to x sub n, is a unique solution to the system, then A inverse exists, and x is equal to A inverse times B. So if you know the inverse, you can find the solution really easily. So this is how it would look. You have AX equal to B, Then if we multiply on the left by A inverse, you get this form. You get A inverse A x equal to A inverse B. A inverse A is the identity matrix. And so you get A inverse B. So identity matrix times x is just x. So x is that solution. A inverse B. So that is basically just like solving 2x equal to, say, like 6. Basically, you multiply by the multiplicative inverse on both sides. 2 over 2 is 1. You can simplify that. And then 1 times x is x, and that's just 3. But the thing is, we don't always have multiplicative inverses for matrices. Not always the case. If you have a unique solution for the system, like if you have a system of 3 equations, 3 unknowns, then they intersect in a point. Then you'll have an inverse. If it intersects in a line, you will not have an inverse. And it's all related like that. All right, so let's look at this example. This is actually one well, I'm not sure actually. Not sure we did this above or not. We did the inverse above, I know that. So let's take a look at negative 2x plus 5y minus 4z where am I at? Equal to negative 20. And then x minus 2y plus z equal to 8. X minus 5y plus 9z equal to 24. So let's write this in the matrix form this time. Instead of doing row reduction and all that, we're going to write the matrix A. So A is the coefficient matrix. So negative 2, 5, negative 4, 1, negative 2, 1, 1, negative 5, 9. Then we have B is the constants, negative 20, 8, 24. So actually what I was saying earlier, those are not your solutions on B, those are your constants. I think I said they're solutions. Those are your constants on the right hand side. X ended up being your solutions. These are your solutions if they exist. Okay, then X in this case is X, Y, Z. And it's that column vector like that. So you have that form AX equal to B, or X is equal to A inverse times B. Like that's the solution. Now, if you look, we already know. So look at A. A is that same matrix. This is my A. Okay, so there's my A. We already have A inverse. So A inverse is this matrix right here. So we already have that. So if we take that matrix, so I'm just going to copy this thing and multiply by B, then we have our solution. So I'll be able to move that around. So X is equal to XYZ, which equals A inverse times your negative 20, 8, and 24. Now it would take a little while to multiply that out by hand. So I'm just going to show you. Well, actually, you know what? Everything reduces. All divisible by 2, so it's actually not as bad as it might look, because everything is divisible by 2 when you do that, so you actually get it to be not so bad. So it's negative 130 plus 100 plus 36, negative 80 plus 56 plus 24, negative 30 plus 20 plus 12, and you get 602. So you get your solution of 602. So that's your order triple solution, 602. A couple of things I put in here to show you. This is a 3 by 3 multiplied by a 3 by 1. Insides match. So the outside is what is the result, a 3 by 1. So practice a few of those. I want you to understand the matrix equation, like how this kind of works, and how multiplying by an inverse will give you the solution. For the exam, it'll probably be simpler, like 2 by 2s, but the same technique might be asked for, but it'll be easier calculations than this. But if you can do the 3 by 3s and understand them, then you'll get the other cases. Okay, that wraps up this chapter. So what was that, 6.4? Yeah, so 6.4, I think that's finished. I'll have to double check, but I think we're down to chapter 6. Chapter 7 will be real quick, and then we'll go on the rest of the time for the last chapter, chapter 8.